Well, if you recall, we saw an example earlier where we took the set x being 1 through 4, the integers 1 through 4, and we had a set D, which was a collection of sets, a set of sets where we had a 1, a 2, 3, and a 4. And we saw that D is a partition because each of those three is their pairwise disjoint and their union is equal to x. Well, for shorthand, rather than writing so many squiggly brackets, we could say that D is 1, just put a vertical bar, separate the numbers that way. It just avoids having to write all the squiggly brackets. And note that we could also do it as 2, 3, 1, 4. These two are the same, because remember, they're collections, they're a set of sets. But in a set, the order doesn't matter. So I very easily could have put 2, 3 first, and then the set 1. I could have switched the order there or any other place. I could have, or we could even say 4, 1, 2, 3. All three of these are equivalent. Well, let's list all the partitions of the following sets. The first one's trivial. There's only one element in it. There's only one partition. That's it, just the element itself. The next one has two elements in it, so you probably want to figure out a nice orderly way of doing it. One partition is take them both and treat it as one partition. There's only one other way to do it. So this is one partition using the entire set, and this is breaking it up into the singletons. The next one, as the set gets bigger, you're going to have many more partitions. Let's look at the set 1, 2, 3. Well, what do you want to start with? Maybe we start with this, the same thing we did before. In other words, all of the elements together. That is one partition. What do we call that? The trivial partition. Then we need to take two of them and one of them. So let's do 1 along with 2, 3, 2 along with 1, 3, and 3 along with 1, 2. So this is the only way that you can break them up into a partition of two sets. Notice that in each one of these situations, we have the singleton here, which is 1, the singleton here, which is 2, the singleton here, which is 3. And if you wrote 1, 2 as 2, 1, it doesn't change it. The set 1, 2 is the same as 1, 2. Order doesn't matter in a set. So we did the individual, we broke it into 2, and now we need to break it into 3. So there's just one more. 1, 2, 3. And that covers all of the bases.